Go.
All right, well, hello everyone, and welcome to the first live session for the Mooc. I'm here with a colleague of mine, Chris Chervon, who will introduce himself in just a second. This is the first opportunity for anyone who's out there to ask us questions live. We have some questions already here that we're going to respond to on the pad. But any questions that you have about the first week of material, we can try to respond to them. In first half an hour will be in English, the second half an hour will be in French. So my name is Greg Gambetta. I'm a professor of viticulture at Bordeaux Sciences Agro in Bordeaux, and I'm a researcher at the Institute for the Science of the Vine and Wine, which is also a research institute for viticulture and enology in Bordeaux. And I'm here with Chris Chervon, who will introduce himself.
Hello everybody, I'm Chris Chervon. I'm here in Toulouse, sunny Toulouse today. I'm a prof in viticulture too, also sensory analysis, and I do a bit of wine with students. I will answer with Greg about the vine biology, doing research on the berry ripening.
All right, well thank you, Chris. So I think we're going to just start with the questions that were already on the pad. I'm looking at them right now. And Chris is going to, I think, treat this first question. And the question is focused on explaining a little bit more about how you do a sodium hydroxide titration and what you're meant to measure acidity in grapes.
Okay, so yeah, sodium hydroxide is basis, so it's alkaline, so, and the grape juice is acidic. So one way to measure acidity in most of the food science industry is to titrate the acidity with some alkaline solution. Here it's sodium hydroxide, the most common one. And you raise the pH to neutrality, which is 7. And then when you reach 7, you measure how much sodium hydroxide you put, and there are conversion tables that can enable you to express the acidity, titratable acidity, in different acids. You can also find that on internet. There are conversion table calculator on internet. I think there is another question regarding whether we can use a pH meter or not. Whether we do that grouping, I group the answer to this question.
Yeah, go ahead and discuss that, Chris.
Okay. So indeed, when you put the alkaline solution in the juice, the pH is going up, and either you have a fancy pH meter to measure the raise in pH, or you can put some solution with some stain. Two are really common: is bromotimol blue, or the other one is phenolphthalein. Both change color around pH 7. There is this marginal error because, they don't change color exactly at 7, but because the grape juice has got no buffer power around 7, one drop of sodium hydroxide, the alkaline solution, will make the juice to make a big jump in pH, and it's not a big error. So that's why using either pH meter or some solution for color change is working. The main problem with the solution is that sometimes the color change goes from yellow to blue green, or from ink color to purple. And if you have a juice that is already really dark, it's not easy to see the color shift. So that's why pH meter is a bit more precise.
I think most of the time people use pH meters, right? So the next question is a question that was written in French. to respond to this question, the question is this, I'll say it in English, and we'll return to this during the French section, is that, you're following a MOOC, there's students out there who are following this course, and the question is, if I sought more courses, either through a university, where would I find them? Where do I find more resources to take courses? Now, it's going to be different if you're in France, wherever you are locally. So I'll answer during this half hour from a Western point of view. So I come from the US, and there's local grower agencies or local universities that have departments in viticulture and enology. So you have to look around you and find where these places have continuing education or industrial-sponsored events that are for education. And so this is often the case when you're in viticultural regions, that you can find courses through these other universities. So moving on with the questions here, we have several questions about vine biology that are pretty interesting. The first question is talking about rootstocks, and the question is, when you go, the student is asking, it's difficult to find advice when you go to a nursery or something like this on which rootstocks would be most appropriate for a certain soil. Okay, and it's asking us to decide. And so this is a very difficult question to respond to, because you're going to choose a rootstock based on your specific context and what you're trying to achieve. So rootstocks are used mainly to protect against phylloxera, which this is true for all commercially available rootstocks. But besides that, which is true for all of them, probably the two other criteria that people use rootstocks for is to modulate the vigor of a vine. This is to say, how big or how vigorously does the vine grow? Does it grow to be really big? Does it kind of restrict growth? This is high vigor or low vigor. This is something that someone will choose a rootstock for. And oftentimes this goes hand in hand with the drought resistance of the vine as well. So is the rootstock going to impart more drought resistance, meaning I need less water use, or less resistant to drought? It's true most of the time that high vigor rootstocks or rootstocks that induce vigor are also the ones that are drought resistant. And the ones that are low vigor are not as drought resistant, or they're drought susceptible. Now, when you're talking about soils, a lot of the times people will use these differences in vigor to kind of homogenize or smooth out differences in soil across parcels. So if you have soils that are really rich in nutrients and rich in water, that's going to promote growth, and you're going to most likely have a situation where your vines are really vigorous. People would choose a low vigor rootstock in these situations to try to kind of tamp down or reduce that vigor. And then the opposite is true. If you're in a soil that is maybe low in organic matter, it's low in water, like rocky, sandy soils, you may choose a higher vigor rootstock to try to overcome the deficiencies that are going to be there. So, but it's a choice that growers make on a parcel-to-parcel basis. They choose what rootstock they're going to use. So that's that question. Moving on here. A question about carbon dioxide, water. I'm translating. This is a question in French, so I'm translating it in my head. And if the vine consumes more water during fruit maturation, and this is not the case. The vine consumes water based on the atmosphere, and if it's warm or dry or not, or if it's cool or cloudy, the contribution of water that goes into fruit is really small compared to the amount of water that just flows through the vine in transpiration. So if you can imagine, think about how much water is in little clusters. The amount of water that flows through a vine on a hot, sunny day, I'm talking about just one vine, can be 50 liters of water. So this is a huge amount of water, and most of it goes into the atmosphere. So it doesn't consume more or less depending on where the fruit are at. It consumes more or less depending on the atmosphere. And then another part of the question asks about where does the water go? and is the water lost to the atmosphere? And indeed it is. So when it gets taken up from the soil, goes through the plant, and goes into the atmosphere, and that water is gone. And the only way you're going to get more water into the soil profile during a season is if it rains or if you irrigate the parcel. Let's see if there's some new questions coming on here. This is kind of fun. Yeah, please.
One point regarding the water. I just thought that we had a chat before. It's not directly linked to the evaporation, but when it's really dry out there in summer, some berry can suffer shrinkage. And according to some physiologists, it looks like the vine has the capacity to take the water back from the berry and just to rehydrate a bit the part of the plant that are close to the cluster. And this berry shrinkage is often a problem for viticulturists because that causes ripening blockade. And it's really linked to water status in the cluster. Yeah, sorry to interrupt, Greg, go for it. Yeah.
Anytime, Chris. You can interrupt me anytime. So I just want to. There's someone following the Mooc asked a question. It's on my pad here. What should we pay attention to when sampling? For example, we need more information. So if you're the one who made that question, sampling what? Sampling berries, I assume, but try to make it more clear. I don't know what you mean by that question. Okay, moving on to another one. This is kind of cool. A student asked if you can take a grape and grow a new grapevine from seed. So can you take the seeds of a grape and grow a grapevine? And the answer to that question is sure. You can totally do that. You can germinate them just like you would germinate any other seed, which is typically to kind of incubate them in cold and a wet environment for a while and then put them in warm soil. So if you really wanted to do that, we don't grow grapevines from seed, though. Typically we grow them from woody cuttings because we want to make sure that there's no change in the makeup of the fruit. So we want to make sure that if we have Cabernet Sauvignon of a certain clone, every time we plant that, the fruit's always going to be the same. We don't want to change the fruit composition. We want to know what we're going to get. There's another question here that's a very tough one to answer, which is how deep do grapevine roots go? And this, actually, the easy way to answer this is that we don't know, normally. The grapevine roots go down to depths that can range anywhere from really shallow rooting systems, much less than a meter, to many, 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 many meters. And it probably mostly depends on the soil structure and kind of the geological structures in the subsoil. If there's like a geological layer that stops roots from going deeper, this is like the classic example is Saint-Emilion. There's a limestone plateau, and it's thought that the roots then are restricted to a really shallow area. But the majority of roots are probably going to be in the top 50 centimeters or meter anyway, because of the fact that that's where the organic matter, where most of the nutrients lie. That being said, if you have a very deep soil with a water table that's way down there and there's nothing stopping the roots from getting there, if you have a mature vineyard that's 10, 20, 30, 40 years old, likely the roots have found that. And we know in trees, this is kind of intriguing, in trees, roots can be hundreds, and that's hundreds of meters deep. So there's no reason to think that a grapevine root couldn't also go very, very deep.
There is one I can answer. Yeah, there is one I can answer, Greg, is one at the bottom, it's asked in English, it's what do you think the best sugar acid ratio in winemaking should be? So that's a really good question, but that's a tough
It's a tough question because it depends, one, how you express acidity and how you express sugar level. Because if you're talking about ratio, the ratio will depend on the units you use as sugar and as the acid, clearly. So first. Secondly, very complex because it depends the type of wine making you're going to use, the wine process you're going to use. In some wine process, you don't perform the malolactic fermentation, and people will talk about that in the module 3 in enology. And that process, the malolactic fermentation, will decrease acidity. If you have a lot of sugar, you expect to have a lot of alcohol, and in that case, you want to maintain a certain level of acidity to have a good balance. So very complex, very good question, but very complex answer. I don't think anybody can answer that, clearly.
Yeah. I don't think so. It's so dependent on the wine, as Chris said, it's so dependent on the wine style that it's a very difficult question to answer. It changes with the style of wine being produced. So there will be a best sugar to acid ratio for what you're trying to produce, but you need to know what you want to do. Well, I think that we don't have any more questions here that I see. So, based on that, I think I'll thank the students that did send in a few questions, and it was interesting to answer them. And thank you for following the live. There'll be another live next week at the same time. That will be for the next week's module, and I'll be back actually myself. So with a colleague of mine from here at Kees van Leuven. So thank you again. Bye-bye.
And thank you again, and see you next week.